All right, so topic 4 is going to be about the Pythagorean theorem inequalities. Other places you might see this as the converse of the Pythagorean theorem, okay? But we need to remind ourselves of something from Unit 3. So the triangle inequality says that 3 sides form a triangle in general when the sum of the 2 smaller sides is greater than the third side. Okay, so down here I've given you a triangle with side lengths 6, 8, and 10. But how do we know this is actually a triangle? I take the 2 smaller sides, 6 and 8, find their sum, so add them together. That's going to equal 14. And then I ask myself, is 14 greater than the third side, 10? And the answer here is yes, so we know that this forms a triangle. Okay? So now that we know this is a triangle, we're going to actually prove it's a right triangle by showing that the Pythagorean theorem works. So I'm going to take c squared and see how it compares to a squared plus b squared and show that they're going to be equal, just like the Pythagorean theorem says. So I know that c here is going to have to be 10 because that's going to be the biggest side. So I'm going to plug that in for c. 10 squared, and hopefully we want this to be equal. So 10 squared hopefully equals 6 squared plus 8 squared. 10 squared is 100, and 6 squared is 36. 8 squared is 64, and then 36 plus 64 is 100, and it works. So this means we know this is a right triangle, and there could have been a right angle across from the hypotenuse. Now, let's do a little bit of a discovery here. What would happen to the right angle if the 10, the side with the length 10, got longer? So I still have this side length 6, and I still have the side length 8, but let's say this side length here, connecting, is no longer 10, but it's stretched open a little bit and has become 11. What happens to this right angle here? Well, if it's stretched open, it's now bigger than 90. So this right angle is now obtuse. And we can see this using c squared equals a squared plus b squared also, because a and b are still 36 and 8. So I know that those will still add to 100 like it did before. But now the longest side is no longer 10. The longest side is 11, and 11 squared is 121. Now, those are no longer equal. Now, it's greater than. C squared is greater than a squared plus b squared. So that's going to tell us something in a little bit. Let's look at a different example. What would happen to the right angle if the 10 got shorter? Okay, let's draw a picture. So, the 6 is still there. The 8 is still there. But let's say this side length now became a 9. Well, if the 10 gets shorter, that's going to shrink this angle down and become less than 90, which means this angle is now going to be acute. And now let's look at c squared equals a squared plus b squared. Again, the 2 smaller sides are still 6 and 8. That's a squared plus b squared is still going to add to 100. But now, again, the largest side is no longer 10, it's 9, and 9 squared is 81. Well, 81 is not equal to 100, it's less than 100, okay? So, let's generalize what the rules are for the Pythagorean theorem inequalities. We know that c is always going to be the biggest side, okay? So regardless of what type of triangle it is, the largest side you're always going to use is c. And if we test the Pythagorean theorem and we get that c squared becomes equal to a squared plus b squared, we know the triangle is right, just like 6, 8, and 10. If c squared is greater than a squared plus b squared, then we know the triangle is going to be obtuse, just like 6, 8, and 11. And then last but not least, if c squared is less than a squared plus b squared, then we know the triangle is acute, just like 6, 8, and 9. So Let's look at some of these examples. It says, given the side lengths, classify each triangle by angles, if possible. I'm going to come back to what this means about the if possible. But classify means my answer should look like this. They should either say acute, right, or obtuse. So let's go through the steps here. On example A, it says the side lengths are 5, 6, and 14. Well, C is going to have to be the biggest side, and then I'm going to test the Pythagorean theorem. So I'm going to look at C squared equals A squared plus B squared. And C is going to be the 14, so 14 squared. How does that compare to 5 squared plus 6 squared? 14 squared is 196, 5 squared is 25, 6 squared is 36. Add these two together, and I get 61. So now 196, that's definitely not equal to, it's greater than 61. So what happens to the triangle when it's greater than when C squared is greater than A squared plus B squared? That means the triangle is obtuse. Okay? Now we actually made a mistake here, all right? I'm going to come back to this if possible part. We didn't actually check from the beginning that these three sides can actually form a triangle. So let's use the triangle inequality to do that. Let's say that 5 plus 6, add the two smaller sides together, that's 11. And is 11 greater than 14? And the answer here is no. So the answer really should have been that no triangle is possible. Okay, so what I want you to do is I want you to cross out obtuse and cross out your work, all right? This is going to be the only example of obtuse, so I wanted you to see that, but we need to remember to always check if a triangle is possible from the beginning. So let's look at letter B, okay? The largest side here is 6. Now, let's take the two smaller sides, 4 plus 2, that equals 6, and ask myself, is 6 greater than 6? And the answer here is also no. So I don't even have to test the Pythagorean theorem, and I can immediately say that no triangle is possible. All right, let's look at C and D. So I just needed a little bit more space here. We're still classifying, but let's look at C. So my largest side is 5. Let's test 3 plus 4 equals 7. Is 7 greater than 5? Yes. So we're ready to test the Pythagorean theorem. C squared, how does that compare to A squared plus B squared? So C is 5. 5 squared, how does that compare to 3 squared plus 4 squared? 5 squared is 25. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. So C squared was equal to A squared plus B squared, and looking up at our notes, we know that that means that the triangle is right. Okay, so this actually forms a right triangle. And last but not least, let's look at part D. So part D says 2, 9, and 9. Now, I'm looking at this here, and I'm realizing that there's not one biggest side, so just pick one of the 9s to choose as your biggest side. And let's add the two other sides. 2 plus 9 equals 11. 11 is definitely bigger than 9. So let's test the Pythagorean theorem. C squared, how does that compare to A squared plus B squared? So I'm saying 9 squared, how does that compare to 2 squared plus 9 squared? And now some of you at this point might be able to see that both sides of this have 9 squared, and I'm adding 2 squared to one of them, so that side's definitely going to be bigger, okay? But let's actually simplify this out for everyone just to make sure. So 9 squared is 81. How does that compare to 4 plus 81? And that means that 81 is comparing to 85, which is definitely now less than, like we had said before. And when C squared is less than A squared plus B squared, that means the triangle is acute. Okay? So good luck on your homework or your classwork, and have a good day.